All right, Algebra 1, lesson 10.8, last lesson of the chapter. And this one just lays a little bit of basic foundation of some trigonometry stuff. Since we're talking about triangles and we've been using the Pythagorean theorem, this one gets us, just introduced to an idea and some terminology that you'll be using more in the future. And so this is lesson 10.8, and it's called Trigonometric Ratios. A little side note, that word trigonometric, I think, is a fun word to say just in how it flows out of your mouth. Trigonometric. Anyway, it's a good word. All right, so I need to get you familiarized with a couple new terms before we can talk about what this is, what's going on here. So I'm going to draw a triangle. This time I'm going to draw it like this. Here's our right angle. And I'm going to use theta. So theta, let me do it a little bit bigger maybe over here. It's a capital theta, like that. It's the Greek letter. I mean, if we spelled it out, it would be theta. It's just one of the letters that is very frequently used. Actually, that's technically a lowercase theta. The uppercase theta is basically the same, but it's like that if I recall correctly. Anyway, so theta, very commonly used as a way of identifying an angle. Okay, so if that's theta, we've already used the term hypotenuse, right? As the side of a right triangle that is opposite the right angle. Well, if theta is here, we're going to call this the adjacent side. And we're going to call this the opposite side. And those terms hold true, opposite of theta, adjacent to theta, and then hypotenuse, regardless of how we orient our triangle. So let's just say I have some other right triangle, and let's say this one I do like this. That side is a little bit off. I meant, yeah, maybe about like that. So here's our right angle this time. And let's say I say that theta is here. Okay, well, here is our right angle, right? So that must mean that the hypotenuse is this one. And then what's the side that is opposite theta? Well, that's this one over here, opposite. So then what's the side that is adjacent to theta? So theta will always be touching the hypotenuse and one other side. So it's the side of the triangle that is not the hypotenuse that is one of the sides that makes up the angle theta, right? If we say that like these two sides make up the angle theta, okay? Erased a little bit more there than I was hoping to, but that's okay. So then this is the adjacent side. Okay. Well, it turns out that if you make multiple triangles that have the same angles, and so let's say we have this triangle, this right triangle, but then I make another right triangle that's just bigger, oops, but that uses the same angles. So if I try to keep that going at the same straightness, about like that. So this one we know is 90 degrees, right? And this one is also 90 degrees. And let's just say that this one is 30 degrees. Well, that's 30 degrees both for the small black triangle and for the big green triangle. And if a triangle always has 180 degrees in the sum of its angles, then this one is 60 degrees, and this one also is 60 degrees. Okay? So we have two triangles here, very different sizes from each other, but with the same angles. Well, it turns out that the ratios of the lengths of the sides of the triangles are the same if the angles are the same. So here's what I mean by that. Let's say that this has a height of 2. Oops, I'm going to go with black there. This has a height of 2. And this has a length of 4. Well, the way that it works for a 30-degree angle is the ratio of opposite to hypotenuse is always a 1-to-2 ratio. In other words, the hypotenuse is always twice as big as the opposite of a 30-degree angle. So if it's 30 degrees, the hypotenuse will always be twice as big as the opposite. So if, let's just say, this one is 5, then we can know if this is 5 and this is 30 degrees, we can know that the whole hypotenuse here, the green hypotenuse, must be 10. Because if it's 30 degrees, the ratio of opposite to hypotenuse is always a 1-to-2 ratio, meaning the hypotenuse is always twice as big. And so this gives us a handy tool to know that just analyzing a wide variety of things with triangles, because these ratios are the same regardless of the size of the triangle. If you know certain information about the triangle, namely in this case, what the angles are, and then you're able to get the measurement of like one of the sides, then you can figure out the rest because the ratios are always the same regardless of the size of the triangle if the angles are the same. You know, two triangles, if the angles of one triangle are the same as the angles of another triangle. And so we've named what these ratios are, and it looks like this, that so this is the cosine, cosine of theta is adjacent, the length of the adjacent side, divided by the length of the hypotenuse. And I'm going to shorten that to be cosine of theta. So instead of spelling out the whole word cosine, sometimes, usually, it's just abbreviated COS. We're going to say COS is adjacent over hypotenuse. All right, we'll abbreviate like that. And then the sine, which the full version is spelled out like that, sine of theta is opposite, the length of the opposite side, divided by the length of the hypotenuse, which the abbreviated form would be like, it looks like sin, but we still pronounce it sine, of opposite over hypotenuse, and then tangent. Tangent of theta equals the length of the opposite divided by the length of the adjacent. Or the abbreviated version, tangent, abbreviated as TAN, tangent of theta equals opposite over adjacent. Okay? So sine or cosine, sine, and tangent, these are kind of like operations that we're doing on theta. Think of it kind of like square root, right? We don't do just square root equals. If I said square root equals 7, well, square root of what equals 7? We don't just use square root by itself. We put something inside of it that is what we're taking the square root of. Similarly, we don't write just tangent or tan by itself. We put something after it that is what we are taking the tangent of. And so there's always an angle that goes after sine, cosine, and tangent. Okay? And it's what we're taking the angle of. And so cosine of theta is saying that for this particular angle, theta, we have a certain ratio of adjacent to hypotenuse. If theta is 30 degrees, then the ratio will be the square root of 3 over 2, is just how that works out. If theta is 45 degrees, then the ratio will be 1 over the square root of 2. Those are just some values that if you end up in like pre-calculus, you'll have some of these memorized. So for remembering these relationships, there's a common, well, if I wrote a very, very abbreviated version, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent, just the t, tangent is opposite over adjacent. Please don't just use S, C, and T to abbreviate these. This is just showing you a way that some students use for helping them remember these when they're first learning them. If we spelled this out, it would be like so, ka, toa. SOHCAHTOA. Right, if you think of it like if you spilled a glass of water on your feet and you're just wearing socks. What has happened? SOHCAHTOA. SOHCAHTOA. Okay? All right. So the types of problems that you'll end up doing, just to get familiarized with these, would be something like this. Write I'm going to shorten trigonometrics just to trig ratios for angle A. And then let's say you're given some triangle, and here's what we have. I'll start out saying this is angle A, and this is 9, 40, and 41. Okay? Well, so then your answers would be that the sine of angle A, so that's opposite over hypotenuse, so that is going to be 9 over 41. The cosine of angle A is adjacent over hypotenuse, so that's 40 over 41. And the tangent of angle A is opposite, so that's 9 over adjacent 40. That's it. Those will be your answers. Okay? Sometimes you'll be given all three of the sides of the triangle. Sometimes you might have to use the Pythagorean theorem, so lesson 5 stuff, in order to solve for a missing piece of the equation. So let's do this like that. So I'm going to orient it differently this time. Let's say this is what you have, and angle A is down here. And I'm just going to make up some values. Let's say what you know is that this is 6, and this is 2. Okay, so we don't know the length of the side opposite angle A. So we're going to have to use our Pythagorean theorem, and if a squared plus b squared equals c squared, then I can say that 2 squared plus b squared equals 6 squared, because 6 is opposite the right angle, so 6 must be c, the hypotenuse. And so then this is 4 plus b squared equals 36, or in others, b squared equals 32. And 32 is divisible by 4, and 32 is divisible by 16. Yep. So b equals the square root of 32, which can be written as the square root of 16 times 2. 16 inside the square root becomes a 4 outside, so this is equal to 4 root 2. All right, so that's that side. So this side is 4 root 2. And now I can write my trig ratios. So I can say that the sine of angle A is opposite over hypotenuse. So that's 4 root 2 is opposite over 6. But now that can be simplified because 4 over 6 can simplify to 2 over 3. So this is going to be equal to 2 root 2 over 3. The 4 over 6 simplified to 2 over 3. And then again, that's the sine of angle A. Okay, cool. Cosine of angle A equals adjacent over hypotenuse, so that's 2 over 6, which that also can simplify to 1/3. So the cosine of angle A is 1/3. And then tangent of angle A is opposite, so that's 4 root 2, over adjacent, which is 2, and that can also simplify. 4 over 2 simplifies to 2 over 1, or just 2. So then I get tangent of angle A equals 2 root 2. And if you're ever not sure whether or not you're simplifying properly, you can use your calculator and plug stuff in and see if you get the same thing. In other words, let's just say we go back to this sine one here, and we have 4 root 2 over 6. I could take my calculator. I could do 4 times the square root of 2 divided by 6. And what I get is about 0.9428. 9428. Then I can take my calculator and I can do 2 times the square root of 2 divided by 3, and I get approximately 0.9428. Cool, I simplified correctly because I'm getting the same thing as what I started with. Okay? That'll always happen if you simplify properly. What you started with and what you simplified to will be the same thing if you get what it is as a decimal. All right? So that's that. And then the last thing that you have for this lesson is just getting used to using your calculator to calculate what these trig ratios are. And here we're going to be using degrees. Eventually you'll get introduced to radians. Radians is a unit of measurement. It's technically kind of unitless, but it's a unit of measurement for measuring the size of an angle, just like degrees, but there are a lot of advantages to radians. And so what these problems look like is it would be like, I forget if it says like use your calculator, but I'll say use your calculator to calculate. I'll say to find, because not really, you're kind of calculating, but to find the trig values. We'll say to the 10,000th place. 10,000th place is 4 decimal places. And it'll look like this. Let's just say we start out with the sine of 17 degrees. Okay. So one of the reasons I mentioned radians just a moment ago as opposed to degrees is your calculator can work with either. And if you are in radians and you input sine of 17, you're going to get the wrong answer. You have to make sure if degrees are the unit of measurement being used, then your calculator must be set to degrees. And so usually there's a erase. There we go. Usually there's either a DEG versus RAD, degrees for radians, or a D versus R that your calculator will show for saying, oh, you're in degree mode versus radian mode. And what it is if you input 17, then your calculator assumes that if you're in degrees, your calculator assumes that's 17 degrees. If you're in radian mode, your calculator assumes that you're in radians. And the two are very, very, very different from each other. To go one full rotation, you need 360 degrees. In other words, 1 degree is 1/360th of a full circle. Versus radians, you need to go a little over 6 1/4 in order to do one full circle. So in other words, 1 radian is roughly 1/6th of a circle, versus 1 degree is 1/360th of a circle. So very different from each other. So usually there's some kind of mode button or something like that that you can use. On the one that I'm using, this is a Casio. I have to go Shift Setup. And when I go Shift Setup, then I have the option 3 to select degrees or option 4 for it to be in radians. So I need to be in degrees right now. And with it in degrees, I just push the SIN button. And then I say 17. And then I hit Enter. And I get my answer is, I wanted blue there for my work versus the question. My answer is blue. There we go. 0.2924. It technically is going to be a 0.2923, but what comes after the 3 is a 7. So I rounded 0.2923 up to 0.2924 because of what came after that fourth decimal value. Okay? Now, what this is saying, again, is that if you have a 17-degree angle, which is pretty small, I'll say that the ratio of opposite to hypotenuse, okay, that the ratio of opposite to hypotenuse is approximately 0.29. So 0.33 is 1/3, right? So that the opposite here is a little less than 1/3 the length of the hypotenuse if this is a 17-degree angle. And we don't know anything about the size of this triangle as far as the lengths of the sides. All we know is that the ratio of the opposite to hypotenuse is a little less than 1/3, just under 0.3, because this is a 17-degree angle right there. Okay? Again, just a little reinforcement of the concept of what's going on. So let's say we did one where we're dealing with the tangent of 209 degrees. Again, calculator, I hit the tan button, 209, enter, and I get blue for my work. I get 0.5543. That's my answer. And one more. See, we have the cosine of 103.2 degrees. Okay, take my calculator, cosine 103.2, and I get negative 0.2284. That would be my answer there. Sometimes you'll get negative answers, sometimes positive. You'll learn later, not in this course, another course, when and why you get negatives versus positives. We're not worrying about that right now. If you're dealing with sine or cosine, your answers will always be between -1 and +1. If you're dealing with tangent, you can get anything. So all of these happen to be between -1 and +1. Um, yeah, tangent can give you much, much, much larger values. Like if I just did, let's just say, tangent of, so opposite over hypotenuse. So I'm going to go with something like tangent of 87 degrees. Tangent of 87 is 19.0811. All right, so you can't get stuff bigger than 1 with tangent. That is this lesson. As always, let me know if you have any questions. But hopefully this is an easy one for you, and it's pretty easy for you to learn the sine, cosine, tangent, the SOHCAHTOA kind of stuff. Okay, cool. See you next time.